I'm going to use the same figure. Oh, I have it over here. I beg your pardon. Okay. So I'm going to again draw our transformation x, y, and z. Yeah. So first thing we're going to do is we are going to determine the resistance force. We are going to determine our resistance force in that direction. So the resistance force over here, I'm going to call this GZ or CZ, okay, and DZ, because they are acting in the Z direction. Okay. So to do that, we have to determine, we have to know the power that's extracted from point C and point D, and we also have to determine what is our EY. Okay. So I'm focusing everything that is on shaft AB. Okay, everything, because shaft AB is what is of interest. Okay, shaft AB. So we are looking at shaft AB, and shaft AB, what I've just done is that is our centroid. So let's calculate our forces. Okay, let's calculate our forces. Okay, determine our EY or CZ, DZ, and EY. Okay. So we know at C, here C, we have a power output. Okay, power output at C is equal, let's recall at C, our power output at gear G or C is 20 kilowatt. Okay, 20 kilowatt. So we know that power is equal to 2 pi NT over 60. Right? So we have 20 times 10 to the power 3, 2 pi RPM, we were given that is 480. We are going to calculate the torque at C and then divide by 60. Okay? So the torque at C is equal to 20 power 3 times 60 divided by 2 divided by shift 5 divided by 480 is equal to 397.887 Newton meter. I will do it again. 20 power 3 and 60 divided by 2 divided by shift pi divided by 480. Yep. Okay. And then we can calculate our CZ. Right. So torque at point C is equal to CZ multiplied by radius at C. So RC, sorry, given RC. So RC is given to be 60 millimeters, right? So that's the radius. So this will be equal to 397.887 is equal to CZ, and then multiply by, that's the radius, 0.06. Okay. So we know now that CZ is equal to 397.887 divided by 0.06 is equal to 6632 or 6631. Let me again, 397.887. 6631. Okay, 6631 or 6632. Okay. So we found CZ, and it's acting that direction. Then we will do the same thing. Okay, we'll do the same thing. Next, we're going to calculate the power at point D. Okay, power output. Okay, we are given that it's 10 kilowatts. Everything the same procedure, okay? So 2 pi nt was 60, so 10 times 10 to the power 3, 2 pi revolution. So we are going to calculate dz divide by 60. Okay, so we can calculate tz, not dz, or td. Okay, so torque at D is equal to 10 power 3 times by 60 divided by 2 divided by shift 5 divided by 480 is equal to 198.944. So 198.944 Newton meter. Let me do it again. Okay, 10 power 3 times 60 divided by 2 divided by shift 5 divided by 480. Yep. Okay. So the same thing is we're going to find, we know that torque at point D is equal to CD, okay, not CD, is our C in our, D in the Z direction, multiplied by a radius of 0.08, or RD. Let me write this out. So DZ will be equal to 198.944 divided by 0.08. So 198.944 divided by 0.08, 198.944 divided by 0.08 is equal to 2487. So I will underline the torques. I will also underline the forces. Okay, and then finally, the last one, I'm going to divide this page so it looks less confusing for you all. So it's still very repetitive. Okay, so power input at point E is equal to 30 times or 30 kilowatt. So this is 30 times 10 to the power 3 to pi 480, okay, TE. Then divide by 60 again. So TE, the same, 30 power 3 times by 60 divided by 2 divided by 5 divided by 480 is equal to 596.831 Newton meter. So a good relationship to find is power input must be equal to what? Power output, right? So if you have to check your answer, if you add these two, 198.994 plus by 379.887, it should be equal to what? 196 point what? 883. Okay. So this is all. So P and C are the torque for the output. Okay. And E is for the input. Okay. Then finally, P at E, this is equal to EZ. No, sorry, EY multiplied by radius of E. So EY. Why is it Y? Because it's coming down in the what? vertical direction. Okay. Well, C and D on the horizontal in the Z direction because it's relative to the what? Point of contact. Okay, I repeat again, it's relative to our point of contact. Okay. So EY is equal to 596.831 divided by the radius of E is 0.16. So 59.831 divided by 0.16 is equal to 373. I get 373. No. What am I doing? 596.831. 596.831 divided by 0.16 is equal to 3730 Newton. Okay. So the one I highlight in blue are the torque. The one I highlight in yellow are the forces. So I'll sketch out the direction. So from here we are going. So from here is easy now. Okay. We are going to find the reactions. Okay. We're going to find. And let me, because of what I've done. We're going to find the reactions at point A and also at point B. Okay, so again, I will copy this image. So when I sketch this out, it will be easy. Okay, so we are now going, so this is our transformation X, Y, Z. Okay, it's important to draw our transformation. So we are going to look at our XY plane. Okay, so this is rotation about Z. Right, so we are going to look at that. We are going to focus on shaft AB. Okay. So this is our point A. This is our point C. Our point D. Our point E. And this is our point F. Okay. So at this plane, we realize that we have a force, right? At this plane, we have a force coming down. Okay. And this force that's coming down is 3730. Okay, this force is coming down at 3730 Newton. And then we have our forces at point C and at point D. And point C or point D is 2487. And at point C is what? 6632. Okay. So apply what I teach you again. Do not analyze the dot and the crosses. Yes or no? It's the same, okay? So we're going to find the reaction at A. So we know that we are going to have a reaction so this is our AY, right? And over here, this is our BY. Okay. So like what I taught you all, do not analyze the cross and dots, okay? Find what is our AY and our our by. Are we clear? We still apply the same. In fact, it is from here I developed the rules for combined loading, okay, by doing this, okay. So it's so much easier. So we are going to take some mention about moment. Z at point A, everything is equal to 0, right? So we get minus 3730 multiplied by a distance of 0.4. Then we get by, no, not 0.4, 3730 is at point E, right? So it's 0.6 plus by by multiplied by 0.8. The whole thing is equal to 0. So by is equal to 3730 times 0.6 divided by 0.8 is equal to 3.